Hi, welcome to Math for All, where everyone can learn more about math. I'm Denise, and today we're going to get an introduction to variables and what they are in math. We will define a whole lot of math vocabulary and finally get to some numbers by evaluating expressions. This lesson will give you a great foundation for some basics in algebra that are sometimes skipped over. We will define a lot of math terms, which sure feels odd to have vocabulary in math, but we need to learn some of the language of algebra in order to understand it later. Before we get started, please head over to my website, mathforall.net, and get the notes that go through this lesson. You can print them out, follow along, and fill in the blanks to have a great summary of variables and help with some ways to write things in algebra. Then you will have everything you need written down to help you in future lessons. Let's get started. First, we'll define what is a variable in math. It is a letter or a symbol. Variables can look like this: X, A, R, etc., or even question mark. What? Letters in math? There are certainly a lot of jokes about how we get used to numbers in math and then they switch it out on us and add letters. Yep, that's where we're at, and letters will be a huge part of your future math learning. There are two reasons why we use variable letters or symbols in math. First is if something can change. It varies, like the number of ice cream cones you buy. Say each cone is $2, the total amount you would pay would be $2 times the number of cones that you buy, represented by $2 times C. Or it can be used for something that is unknown, and a lot of times you have to figure it out. We will have to solve for x, as in something like this: 4x minus 2 equals 10. Let's go through a little more about how a variable can stand for something that can change. We will have many videos expanding on solving for x, so we won't go over that in this one. Say I want to know how much money you have in your pocket, and you only have $5 bills. The way that I can figure out how much money you have is to take how much each bill is worth and multiply it by how many you have. Like if you have one bill, I know you have $5. 2, then you would have 10. I hope you have 100 of them, because then you would have $500. And if you had $500, you can share. We can write the equation or formula to tell us how much money you have using a variable for how many bills you have. The amount of money you have in your pocket equals $5 times the number of $5 bills you have. Math people don't like to write a bunch of words down, so we will simplify it to T equals $5 times B, where T equals the total amount of money you have in your pocket, and B equals the number of bills that are in your pocket. Now let's use this to figure out how much money you would have if B equals 20, which means that you had 20 of those $5 bills. Put it into our equation. T equals $5 times B. B equals 20. So T equals $5 times 20, and 5 times 20 equals 100. So you would have $100 in your pocket. This was a basic example to show how we can use variables in math to stand for values that can change. Here's another one. We have a rectangle here with an unknown length L and width W. I always write my length L's in cursive so they don't look like ones. I want to find the equation or formula for the perimeter of this rectangle. Remember that perimeter is the amount of fence around it. So going around the edges, I have L plus W plus L plus W equals the perimeter. I'll call that capital P. Now I can use whatever the length and width are and put it in to find the perimeter. If the length was 40 feet and the width was 25 feet, what would the perimeter be? We'll use our formula, and whenever we see an L, we'll put 40. And whenever we see a W, we'll put 25. 40 plus 25 plus 40 plus 25 equals P. Add them up. I'm going to add the 25 plus 25 first. 50 Then 50 plus 40 equals 90. And 90 plus the other 40 equals 130 for a perimeter of 130 feet. You can see how it's not so bad if they give you the formula and the values for the letters. You just plug it in and use the numbers to figure out what it equals. The money and perimeter examples showed you how variables can be used in formulas, and then once we know what our variables equal, we can use that to find out other information. Now we will go over the difference between an expression and an equation. An expression in math is not a facial expression or an emoji. For us, it is just a combination of letters, numbers, and math operations with no equal sign. Here are some examples of expressions. Voila! When you see these, you evaluate them by putting in numbers that are given to you, or you simplify them by combining what you can. An equation, on the other hand, has an equal sign. It almost has the word equal in it right here. Here's what they look like. You'll notice they're expressions on either side of the equal sign. See, each side by itself is an expression, and when I put them together, it is an equation. For these, we will find out what equals what. Usually, it will be a variable equals a number, like y equals 3. Most of algebra will be solving all sorts of different equations like this. Within these expressions and equations, you noticed some numbers, letters, exponents, as well as addition and subtraction. We have some special names for a few of these, so we will define two things: coefficients and terms. First, we'll talk about this weird word called coefficient. The numbers in front of letters, like these that popped up in yellow, are called coefficients. We will add and multiply coefficients later, so remember that name. Also, if there is not a number in front of a variable, the invisible coefficient is 1. For example, in -4ab plus b, the coefficient in front of the ab is -4, and the coefficient in front of the b is 1. But we don't write 1b. It just doesn't look right. Also, you should always put the coefficient in front of your letters. You should write 11y, not y11. It's just the math tradition. Terms are the items separated by plus or minus signs. We can name the terms and tell how many there are. For f squared plus 56g minus 3f, each of these that I will circle are their own special unit or term. So there are 3 terms, and the terms are f squared, 56g, and -3f. Notice the plus or minus sign in front of it is attached to it. That term is not 3f, but -3f. Phew! Thanks for sticking with me on all of these words. Let's take a break from the math vocabulary and do just a bit of real math. Let's learn how to do something called evaluating expressions. This means to give me the number that the expression equals. Take this example, 6r plus 7, where r equals 3. Our job is to put the number where it goes, do some math, and tell them what the answer is. Since the r equals 3, where we see the r, we will put in a 3. One thing to watch out for is that even though the 6 and the r are right next to each other, they don't make 63. You need to remember that there is an invisible multiplication sign in between them, so we should write it with a dot between them like this: 6 times 3 plus 7. Now we follow our order of operations and do 6 times 3 first, which is 18. Then plus 7 equals 25. When I evaluate this expression, I get 25. This next one is just a little more complex. Evaluate this expression. Parentheses wx minus 4, parentheses y, where w equals 3, x equals 4, and y equals -2. Notice we have the expression, and there's not anything that we can do with it unless they give us more information. So they have to tell us what the variables in there equal. For this example, they say w equals 3, x equals 4, and y equals -2. Now we can evaluate it. The first step is to put a 3 every time we see a w, a 4 every time we see an x, because that's what they told us it is, and then put a -2 every time we see a y. There's some invisible stuff going on, so let me show you what's happening between these letters and numbers and parentheses. First, what does WX mean? It does not mean to put the numbers right next to each other, not 34. Never, never, never do that. I will X it out right away. Two variables next to each other mean to multiply. So WX is W times X. Sometimes I put a little dot in there so you can see it. For us, W equals 3, X equals 4, so we have 3 times 4. I'll keep going along my expression. -4 and parentheses y, which equals -2. Here's another thing that can be confusing. When you have parentheses next to a number, it also means to multiply. So do not write it with the parentheses, then the -2, because that would tell me to subtract, and I just told you that it should be multiplied. So we can either put a dot in between like this, or we can put the -2 in parentheses, which also means to multiply. Now we're set up and ready to go. We get to do normal math. Using our order of operations, we do parentheses first. So there's 3 times 4 minus 4. 3 times 4 equals 12. Minus 4 from that equals 8. This whole group equals 8. Then it's times the -2. 8 times -2 is -16 for our final answer. Once we know how to put the numbers where they go, it's just normal math after that. I have one more thing to show you today. It is one of the most confusing things in algebra, and they always like to test on it because a lot of students don't ever learn it. So listen closely and you will see that this is actually pretty logical and uses what you already know. These are two similar but different expressions. X squared when x equals -5 and -x squared when x equals 5. Let's tackle the first one. Evaluate x squared if x equals -5. Remember, what we do here is put a -5 every time I see an x in my expression. -5 with the little 2. However, whatever x is squared, and if x equals -5, that means that -5 is squared, not just the 5. So please put the -5 in parentheses so that I know that the -5 is squared. Another way to look at this is that x squared is x times x, so I put a -5 in both places. Either way you slice it, I have -5 times -5, which equals a positive 25. Now this second one, evaluate -x squared when x equals 5. This time the negative sign is hanging out in front, and only the 5 is squared like this. I'll put the 5 in parentheses to show that that's the part that gets squared. Order of operations says to square the 5 first, then put the negative sign in the front. 5 squared equals 25. Then plop the negative in front, so the answer to this one is -25. Notice the difference in these two examples. Now let's try a couple more. We'll practice determining if the answer is positive or negative. You can do it. Here they are. D cubed when d equals -3, and -d cubed when d equals -3. These are a little different from our previous examples, but they work the same. First one, I cubed d, which equals -3, so I'll put that here in parentheses because -3 gets cubed, not just 3. -3 times -3 times -3. -3 times -3 equals positive 9. 9 times -3 equals -27. Next up, Negative d cubed when d equals negative 3. The negative sign again is hanging out in front, so I'll put that here. Then the d cubed once again is in parentheses, negative 3 cubed. Do not turn the negatives next to each other into positives. Order of operations tells us to do exponents first, so let's do that. Negative 3 cubed is negative 27, as we discovered before. The negative sign here tells us to change the sign of whatever the answer is. So the negative 27 turns into positive 27. To encourage you, these types of problems are one of the most confusing there are in algebra, so review these 4 examples carefully if needed. Great job sticking with all this math vocabulary and difficult concepts. You have learned about variables and what they're used for. Remember, there's something that can change and something that is unknown. Also, what terms and coefficients and expressions and equations are. And finally, now you know what to do when you are asked to evaluate an expression. Just put the numbers in for the letters and do math. You also learned one of the trickiest things there is in math. Great job learning this kind of weird stuff. Now print out a worksheet from my website, mathforall.net, and practice your newfound knowledge.